All right, so we covered doubled angles, and now we're going to get into half angle formulas. These are a little bit more challenging to prove. If you're interested, there is a proof in our text, and I will post a proof. But I decided to not take time in the video to show it to you, just because there's enough to cover in this class. So here are your half angle formulas. We have a half angle for sine, so our angle divided by 2, which is known as a half. We have a half angle for cosine and also for tangent. Now this is the really important thing. Our formulas give us this plus or minus business. Your answer is not both, okay? And hopefully that sits well with you. Like cosine of 45 degrees is root 2 over 2. It's not plus or minus root 2 over 2, right? You are living in a certain quadrant, so you have to either commit to a positive or a negative. How you commit to that, making that decision, is this is based on where your half angle lives. This is really, really important. Now for this tangent one, you can use this formula. This is the one that comes with your text. But there's another formula that is also 1 minus cosine, let me be consistent with my variables, cosine alpha over sine alpha. So if you would like, and I'm going to write this in an email, you can prove to me that those two things are the same. You'll get some bonus points on your exam. So let's just use these formulas. This is similar to the sum and difference idea, where this is nowhere on my unit circle. Well, forgive me, that I can easily find. It does exist on the unit circle, but I don't know the exact value, so I'm a little bit stuck. So this is when we manipulate it to be something that we can find our unit circle. So the idea here is very first thing, decide where 22.5 degrees lives. Which quadrant are we in? We are in the first quadrant. So let me ask you, would that make your sine angle positive or negative? Well, from the first quadrant, it has to be positive. So right off the bat, I'm not going to write this plus or minus. I'm just going to leave it as a positive. All right, the next thing you do is you need to double this. So if I multiply that by 2, I get 45 degrees. The reason I doubled it is because if I half it, then it's exactly the 22.5, right? So all I did was rewrite this to be this. They equal the same exact thing. And now my 45 becomes my alpha in that equation. So again, I'm choosing the positive. I'm not going to write plus or minus. So it's the square root of 1 minus cosine 45 degrees over 2. And I put a unit circle here that we could refer to, but hopefully we're okay. We know this one. So we get 1 minus root 2 over 2, and this whole thing is over 2. Here's another important thing. Make sure your square root covers this whole ratio, because it's not just the square root of the numerator, it's the square root of everything. So make sure that this covers the entire thing. Now this really is testing your ability with fractions, okay? So you can find a common denominator in that numerator. Another option is I can multiply numerator and denominator by the same thing. I'm not changing the problem, right? You're multiplying by 1. because now you get 2 times that 1 is 2 minus root 2 over 2 times that 2. Those 2's will reduce out, so I get root 2. And then this 2 times this 2 is a 4. And again, look how my root kind of stopped covering everything. So make sure it does. Sometimes I like to put a little tail so that I know it ends right there. Now, if you can, I don't know what the square root of 2 minus root 2 is, so I'm going to leave that. But I do know the square root of 4 is 2. So I am going to take the square root when I can. If you ever wanted to see if you're right, you can put in your calculator sine of 22.5 degrees, see the decimal it gives you, and then put this in your calculator and see if it gives you the same decimal. This would be on a non-calculator portion of your exam though. Okay, so for this next example, cosine of 165 degrees. This is not on, it is on the unit circle, but I don't have a clear coordinate for it. So again, first thing you decide, where does 165 degrees live? So I'm just going to go to the side. That would have to be quadrant 2. What is cosine in quadrant 2? Positive or negative? These guys are negative. So I'm choosing the negative. I'm not going to write plus or minus. The next side step you get is you want to go ahead and multiply it by 2, because then if you have it, you get the same exact thing you started with. So I'm going to rewrite this to be cosine of 330 degrees over 2. And I'm going to choose this formula right here. I'm not going to write plus or minus, so it's just a negative. And it's 1 plus cosine of 330 degrees over 2. 330 degrees is right here. So my cosine there is 1 plus, my cosine there is root 3 over 2, and that whole thing is over 2. I can't leave it like that. I should clean it up. So I'm going to multiply numerator and denominator by 2. Multiply that 1 by a 2, I get 2, plus root 3 over 2 times 2. Those 2's reduce out, so I get root 3. 2 times 2 is 4. Again, make sure that root is covering everything. If you can take the square root of something nice, go ahead and do it. And the square root of 4 is 2. And I like to also, at the very end, say this is cosine of 165 degrees. So I should do it up here too. This is sine of 22.5 degrees. So that clearly is not something that is listed on our unit circle. But this is really important to know because now you can find the exact, where if you use your Desmos calculator, it will just give you a decimal. Now, back in the day, we required you to use TI-89s, and it would give you the exact. And so on your calculator, on a TI-89, if I put in cosine of 165 degrees, it would give me negative root 3 plus 1 times root 2 over 4. And the reason I'm talking about this is because it's nice to test some algebra skills. Another opportunity for some bonus points is proving this value is equal to this value. You can manipulate both sides if you like. So far we have this opportunity for extra points towards your Chapter 6 exam, and then also proving these two values, or expressions I should say, are equivalent as well. And I'll send out a reminder about that. All right, so we are going to go to our last example. I should mention too, if you're checking in the back of the book for these answers, sometimes they don't look exactly like yours. So I would suggest putting it in your calculator and see if they give you the same decimal. All right, here is this beauty. So it looks like I'm going to have us find half angles for every single one. So this is more abstract. This would be on a calculator section, where this one wouldn't be because you could just put in cosine of 165 degrees. So I'm given here the sine of alpha is negative root 3 over 3, and it tells me where it lives. And if it's between 3 pi over 2 and 2 pi, again, I like to draw triangles, why not? Then that means I'm in the fourth quadrant. My sine is opposite over hypotenuse. I need to find that missing side, so I'm going to go ahead and do my Pythagorean theorem. And I'll say that's x squared plus negative root 3 squared equals 3 squared. X squared plus 3 equals 9. X squared equals 6. Sorry. Equals 6. And we end up getting x is root 6. All right, so I'm going to put that there. I know our formulas are on the other side, or this piece of paper, but we are going to, I'll just give them to us in this portion. All right, this is one of the hardest things for students is, again, I can't write plus or minus for these formulas. You either commit to a positive or a negative. So we need to figure out where our half angle lives. And to do that, we have that our angle lives in the fourth quadrant. But what I'm going to do is I'm going to half my angle, because I want to know where that guy lives. Well, you have to be consistent and do it to everything. So if I have 3 pi over 2, I get 3 pi over 4. I get alpha over 2. And I get pi. So let's think about that. 3 pi over 4 and pi, that would be in the second quadrant, correct? Another way to think about this is choose an angle in the fourth quadrant. So like 300 degrees. If you half that, that's 150, and that puts you in the second quadrant. So you can choose a value, just make sure you choose the correct value where it should be. So my values here are negative and positive. So that means my cosines will be negative and my sines will be positive. And I'm going to go ahead and write out this formula. Sine of alpha over 2, I'm just going to write the exact formula, just so I have something to refer to, is 1 minus cosine alpha over 2. Hopefully you're okay with this. I am going to choose, it's the positive since I'm in this quadrant. So it's the square root of 1 minus, well let me name my angle what it should be. So it's an alpha. Let's go ahead and just, it's not a theta, it's alpha. All right, so my cosine here is root 6 over 3, and this whole thing is over 2. So this one's a little different because these guys aren't matching up like the other time. So what I'm going to do is I'm just going to choose what they have in common. So I'm going to choose to multiply 3 and 2. The value they have in common is 6, the lowest. And I'm going to go ahead and multiply. So I get that 1 times 6 is 6. Now again, testing your fraction knowledge. Please ask questions because this never goes away in mathematics. That 6 times that root 6 over 3, that 3 and that 6 will reduce to be 2. And what is 6 times 2? 12. Now, I did that to get rid of the fraction within the numerator. This is just one method. There is another way you could have done it. But now I'm going to go ahead and reduce, because all of those guys have something in common. And it happens to be a 2. So I have a 3 here. I have a root 6. And I have a 6. Now, I am fine with you leaving it this way. If you're checking the back of the book, they would make you go ahead and rationalize this. So I multiply, let me rewrite this real quick. This is saying this is 3 minus root 6 over root 6. This means the same exact thing. And because we can't have a radical in the denominator, we need to rationalize. So I end up getting, it's going to be pretty, 3 times root 6 is 3 root 6. Root 6 times root 6 is just 6. And this whole thing is over 6. If you were checking in the back of the book, they write it a little bit differently. And they say, okay, well, I'm going to factor out a root 6. So they say this is root 3 minus root 6. And then they take out this root 6. And this is all over 6. That is not necessary for me, but I just wanted to show you this is an acceptable answer. If you want to rationalize, this is an acceptable answer. And if you're checking in the back of the book, I believe they write it like such. They factor out that root 6. All 3 are A pluses. Okay. Why don't you pause the video and try to do cosine of alpha over theta and see if you get it right. So, and once you do it, unpause it and come back to me. All right, so this one is cosine. So that formula is plus or minus root 1 plus cosine alpha over 2. I am going to commit my answer to be a negative since I'm in that second quadrant. I get 1 plus cosine of alpha is root 6 over 3, and I divide it by 2. And another way we could have made this, clean it up, I should say, versus, the way I showed right here, is I could go ahead and combine that numerator, and I get 3 plus root 6 over 3, and that whole thing is over 2. Again, make sure that root is covering everything. And then that 3 and that 2, because I'm dividing, I get 3 plus root 6 negative, and then that becomes, forgive me, let's go ahead, and I want this to be over everything, and that goes over 6. So 2 different ways to clean that guy up. And that is your answer. Again, you can leave it like that, and I'm going to, just to save some time, or you can rationalize it. We just don't have a lot of time to rationalize all these things. That's not what I'm testing you on. Okay, so for tangent of alpha divided by 2, which we haven't done one yet, I'm going to use that much easier one that says 1 minus cosine alpha over sine of alpha. So with this formula, I don't have to choose plus or minus. But let's think about it logically. If I'm in this second quadrant, my tangent should be negative. So hopefully my answer is negative. So these tangents are a little bit more challenging. 1 minus root 6 over 3. And my sine is negative root 3 over 3. I cannot leave it like that. All right, we have to make this look better. So one option is to combine our numerator. So we end up getting 3 minus root 6 over 3. And that whole thing is over root 3 over 3. When you divide by fractions, we have to go ahead and multiply by the reciprocal. If we look here, we can reduce this out. And so now we're looking at 3 minus root 6 over negative root 3. Again, because of time, I can go ahead and leave it like this, but I do want to show you with rationalizing, because again, that doesn't go away. I'm going to go ahead and multiply numerator and denominator by negative root 3. So distribute that, I get negative 3 root 3 minus, oh, that gives me a positive, and that actually gives me root 18. And then a negative times a negative is positive. Root 3 times root 3 is 3. Well, now I gotta simplify that guy. So you can kind of see why I'm not going to require you to do this on the exam. It just takes way too much time. 18, that simplifies to 3 root 2. And then this is over 3. And then we have here these 3's can all be reduced since they are all there. So we have negative just root 3 plus root 2. And this is, in fact, a negative, right? Because negative root 3 is bigger than root 2. And that is your answer. So you can go this far. Pretty rad if you do. Or I'm happy with you to leave it here. Okay, see you next time.